Hey folks, welcome to part 2, going through balancing equations. So we have a little bit for us to cover. Just to go through some examples. In the previous video you saw how to go through balancing equations, so hopefully we'll be able to get a little bit of practice to give you an idea on how to do them. So here's some steps for balancing equations. Step 1 would be to write out the word equation for the reaction. Step 2 would be to take that word equation and turn it into a skeleton equation. Step 3 would then begin to count the number of atoms for reactants and products, and then step 4 is to balance the number of atoms by using coefficients. And then at the end, step 5 would be to reduce if possible, and I'll show you a example of that as we start to move forward. So let's take a look at 3 separate problems here. So these 3 begin and basically just say, to balance the equations that we have. So there's no word equations here, so we can kind of skip right to step 2 where we have our skeleton equations, and we're going to move on to taking a look at the number of atoms in each one. So let's start off and list out the atoms for each one. We'll walk through these together. So I've got iron and oxygen. Those are the 2 that are present in each one. Iron and oxygen. So I have my reactants and I have my products, and let's count out the atoms for each one. So in the reactants, iron, it looks like I have 1, and oxygen I have 2. Iron on the right hand side, we have 2, and oxygen we have 3. So neither of them are balanced straight away. So as I add in coefficients, remember coefficients go before either a metal or they go before a compound. They're the only place that you're allowed to add in numbers to change this around. So in this one, they could go here, here, or here. So let's start to see what happens when we balance these out. I need to balance iron and make it from a 1 up to a 2. I can't make anything smaller. I can only make it larger by increasing the number of atoms or molecules. So if I increase iron up to a 2, that means I'm going to have to place a 2 in the front here, because 2 times the 1 gives me my 2 that I need. Now after that, it looks like iron's good. So oxygen, though, has a 2 and a 3. And in this case, in order to balance this out, I don't have a number I can multiply 2 by to give me 3. I can't just multiply it by like a given fraction or anything like that. So what I would do in this case is to look for the lowest common multiple they share, and I would get 6 as an answer between 2 and 3. So I'd have to multiply 2 times 3 to give me 6. So I'm going to place a 3 here. That gives me 6 oxygens. And then I'm going to place a 2 in the front here. I just want to affect that oxygen, but I can't place anything that just affects the oxygen. By putting a number in the front, it also affects the iron too. But it does help me because 2 times 3 does give me my 6 oxygen. But it does change my iron value from 2 up to a 4. So then, okay, oxygen's good now. Now I have to go back and take a look at iron. Well, how can I change what I have to give me a 4? And really all I need to do is just get rid of this 2 and change it to a 4. Now I have 4 irons. I have 6 oxygens in each one. And so I can double check my group by looking at my coefficients. 4 irons in the reactants, 2 times 2 gives me 4 in the products. I have 3 times 2 oxygens in the reactants to give me 6 in total, and 2 times 3 gives me 6. So I have the same numbers, and the equation is balanced. The coefficients I could write as 4, 3, and 2. Let's go on to our next one. Again, maybe I'll get you to try the next one out and see if you can figure it out. So pause the video, see if you can figure it out, and then come back when you're ready, and we'll go through the answer for it. All right, so hydrogen, arsenic, and oxygen. Have my arrow, my line, just kind of separating them from reactants to products. Hydrogen, arsenic, oxygen. So we go through and start counting atoms. Hydrogen, there's 3. Arsenic, there's 1. Oxygen, there's 4. If I look at my products, I can see I have 2 separate spots where oxygens are. I'm going to have to add those together. But I have 2 arsenic. Looks like I have 2 hydrogen and my oxygen value, I have 5 in the first one and 1 in the next one, so that means I have 6 in total here. So now if I want to balance this out, now what I need to do is to start at the left and just work my way across. So I'm going to start with hydrogen. Okay, I have 3 hydrogens in one and 2 in the other. I'm going to use the same kind of approach that I used in the last one. I can only add numbers in the coefficient spot, and so I'm going to place a 3 here and a 2 here because that's going to give me 6 hydrogen, and then I'm going to deal with the how it affects the rest of it as well. So now this looks like it gives me 2 arsenic. It looks like it gives me 8 oxygen altogether, so I've doubled everything there. On the other side, it looks like now it's giving me 8 oxygen because I have 3 times the 1 plus an additional 5 on the other side, so that gives me 8 in total. So now if I take a look, I have 6 hydrogen, I have 2 arsenic left and right, okay, going back and forth here and here, back and forth here and here, and back and forth here and here. I actually balance this out just by doing that one step. And so what would this thing look like in terms of writing out coefficients? It would look like 2, 1, and 3. Now let's say that you didn't notice that right away and you kept going. Just for an example, let's say that you did balance it at the end, but you managed to get 4, 2, and 6 as a balance. Do you see how each number there is divisible by 2? So that's step 5 that I mentioned from earlier, where you can take numbers that are in common, if they all share a common factor, and divide them by that number. And if you do divide each one by 2, you'll just end up getting this again. So whenever you have your final answer, you should always try to reduce it down to its lowest term, to something that can't be reduced anymore for the coefficients. So let's take a look at the last one. Again, same as before, I'll get you to pause the video, give it a try, and come back when you're ready. Alright, so for this last one, it actually has a little bit extra, kind of a little trick to it. Do you see how NO3 is showing up in both parts? I could completely separate these as nitrogen and oxygen and it would still work and I'd get the right answer. But NO3 itself is a polyatomic ion. It's a group. So because I have NO3 in brackets in each case, what I would encourage that you do for this is that I'd actually keep it as NO3 and NO3. And then that way collectively you know the stuff inside the brackets doesn't change. And so I have 2 on the outside for one and 3 on the outside for the other. Well, okay, so I have 2 here and I have 3 here. How am I going to balance it? Well, from going through it before, we know that if we put numbers in the front, that helps to balance them out. And between 2 and 3, we can make 6. So I'm going to put a 3 here and a 2 there. Now all of a sudden I have 6 NO3s on this side and I have 6 NO3s on this side. This thing is balanced. So whenever you recognize that the same compound is in brackets in the reactants and the product side, you can actually use it as a group to help you balance a lot faster and make things a lot easier on yourself. Now I didn't have to do that. I could have written out nitrogen and oxygen on this side, and I could have written out nitrogen and oxygen on this side and gone through and did the balancing rules for them. And so all I would have said here was that I had 2 nitrogen and 6 oxygen, and on this side I had 3 nitrogen and 9 oxygen, knowing that I'd have to try to balance this out afterward. And using the same kind of trick from nitrogen, if I had 2 and 3, I would have ended up writing the 3 and the 2 here, which would have actually given me 3 nitrogen times 2 more gives me 6 nitrogen on each side. And then it would have given me the oxygen values. 3 times 3 is 9, 9 times 2 gives me 18. And 2 times 3 is 6, 6 times 3 is 18, and I would have ended up in the same spot having 3 and 2 as my answer, because the nitrogens are the same and the oxygens are the same. It's just a lot less work if you recognize that the polyatomic ions are there in the reactants and the product side in the same thing. So, the next thing is really just to go through and take a look from a word equation perspective and see what this looks like. This would be kind of starting from the beginning and really working our way through, and you'll see a couple of questions that are like this that pop up from kind of time to time, but the majority will be just given the formulas already. So I am going to go through the answers for each one of these in the next video, which kind of wraps up our stuff on balancing equations.